When you observe an image from only one eye and compare it with the other, you'll notice a movement. This shift is called parallax. Astronomers can use this technique to observe distances to objects in space. How this would work for a star is by an astronomer observing it at one point in the Earth's orbit around the Sun. And then during a second point, he would observe the same star later in the year. The difference of the image between these 2 points would give us a measurable shift in parallax. That will allow the astronomer to determine how far away the star is. The further away the star is, though, the smaller our parallax measurements become, so at a certain point, we won't be able to see a shift at all. This point is of a distance somewhere around 200 parsecs away, or a little over 3.8 quadrillion miles. Now that may sound far, but it's really a small distance on the cosmological scale. So now we need a way to measure further. This is when we upgrade to a system known as spectroscopic parallax. Spectroscopic parallax involves using a well-known chart known as the herzsprung-russel diagram, or HR diagram for short. This chart shows a star's spectral type in relation to its luminosity and surface temperature. The plotted stars are also organized by size, where the smaller ones are more towards the bottom left, and the bigger ones are more towards the upper right. The way this is used is pretty simple. As we look at the star, we measure the brightness as it appears to us, along with an analysis of the light with a prism. This reveals the star's fingerprint, or spectral lines. The varying widths of these lines show what type of star it is and allow us to estimate the star's true luminosity. Next, since we know the real luminosity, we can find the distance. For example, if you saw your cell phone light up from a distance, since you know how bright your cell phone is, you'd be able to guess just about how far away it was. The same principle applies here. If you find the spectral type and estimate the luminosity, you'll be able to calculate for the distance to the star. This method allows us to estimate for further distances of up to 500 times more than those of regular stellar parallax. But this means even using spectroscopic parallax must come to an end. So to measure further, we move on to using objects other than stars, like the spin of a galaxy or the flash of a supernova. So that's also where this video comes to an end.